everyone, myself Umadevi. Me and my teammates Pooja, Kavya, Rahul and Mercia are doing a project on IDTReeS, that is, integrating data science with trees and remote sensing. Nowadays, the information about the forest is very important. To identify them and classify them is a crucial task. This is only possible with remote sensing data. So, we are provided with two sites, OSBS and MLBS, which contains the remote sensing data. We are doing this project in two steps by classifying them and by delineating them. Delineation process is identifying the top of the tree crowns, that is the sun exposed area, and classification means categorizing them by their taxonomic names.
The dataset used in this competition has been provided by the IDTReeS competition 2020. The data has been derived from three sources. The first two involves the remote data as well as the field data, which are neon data, and the third is the individual tree crown data, which has been provided by the IDTReeS research group. The remote sensing data consists of 345 images consisting of RGB images, hyperspectral images, canopy height model images as well as the LiDAR images. The ITC consists of the individual tree crown delineations, where each delineation is a two-dimensional bounding box which represents either the maximum tree crown boundary or the extent in the north, south or east-west direction. The field data consists of the labels to be provided to the images, which consists of the individual IDs, the scientific names, etc. And each row of the field data has been bounded to the ITC bounding boxes. For the purpose of this project, we have created a geodata frame by merging the ITC data as well as a field data by the individual ID attribute. And for matching the ITC bounding boxes to the remote sensing data, we have done hand annotations of by finding out the coordinates of the bounding boxes.
Deep forest is the model used for predicting tree crowns using RGB imagery. It uses deep learning object detection network to predict the bounding boxes corresponding to individual trees in RGB imagery. It is built on Keras RetinaNet package, and it is the first open source implementation of a deep learning model for crown detection. A LiDAR unsupervised algorithm generates initial tree prediction. The bounding box for each tree is extracted and the corresponding RGB crop is used to train an initial deep learning.
Forest is an open source tree detection and classification model. For training this model, we have to convert the shapefile and the training data CSV file into a common CSV file, which is in the following format. Image path is self-explanatory. The path where the image is stored, xmin, ymin, xmax and ymax are the endpoints of the bounding boxes where the trees are located. The label is used for classification of these trees. For evaluating, we have to give the input as any RGB image, and the model will detect its tree crown delineation for that image. For our data set, we have to convert this image into all the TIFF images into a PNG format because the dimensions of the TIFF images were different. We were successfully able to detect the tree crowns from every image.
Our project aimed at identifying and classifying individual tree species from remote sensing data. For this, we used a pre-trained CNN model, Deep Forest, which successfully predicted individual tree crowns and classified them to a single class. Even though we couldn't achieve the expected accuracy for our model, we were able to explore more in the area of deep learning, and that was a great experience for all of us. This project can be expanded in future for classifying tree species of different forests using remote sensing data. Finally, I thank Bennett University and Leading India for giving us this opportunity, and also our mentor Dr. Shakti Sharma sir for helping and guiding us throughout the project. Thank you.